Imagine trying to crack a safe with trillions of combinations. A classical computer would take thousands of years, but a quantum computer could solve it before you finish your coffee. Welcome to quantum computing, where quantum physics supercharges classical logic. Today, we'll explore what quantum computers are, why they're hyped, and how they'll change the world. By the end, you'll understand quantum computers and be able to casually discuss qubits. Let's start with the basics. Your phone, laptop, and supercomputers all run on bits. A bit is a tiny switch, either 0 or 1 on or off, storing and processing information. But in the quantum world, things aren't so simple. Enter the qubit. A qubit is like a bit's rebellious cousin. Thanks to superposition, a qubit can be both 0 and 1 at the same time. It exists in both states simultaneously until measured. It's like a spinning coin, a fuzzy combination of heads and tails. That's a qubit in action. Now imagine thousands of these spinning coins, all linked together. That's the foundation of a quantum computer. But it gets weirder. Superposition is only half the magic. The real secret is entanglement. Einstein called it spooky action at a distance. Entangled qubits are linked, no matter how far apart. Change one and the other instantly changes too. Like dice always rolling matching numbers, even across vast distances. Harnessing entanglement connects qubits into powerful networks where solving one part informs the others. This allows quantum computers to process information in ways classical computers can't. You might wonder why we need quantum computers if your laptop works fine. Classical computers are great at step-by-step calculations, very fast. But some problems are so complex that even the fastest supercomputers would take millions of years to solve. These include simulating molecules for new medicines, optimizing global supply chains, or cracking encryption. Quantum computers think differently, exploring many possibilities at once. That's the quantum advantage. Let's discuss what quantum computing could actually do in the real world. Imagine designing new drugs. Scientists currently test molecules one by one, like finding a needle in a haystack. Quantum computers can simulate molecular interactions at an atomic level, accelerating the discovery of new medicines and treatments. Banks deal with immense uncertainty, predicting market shifts and optimizing portfolios with billions of outcomes. Quantum computing can analyze these possibilities simultaneously, leading to smarter financial decisions and changing global money flow. From Amazon deliveries to airline schedules, logistics involves optimization problems, which quantum computers excel at. Imagine minimizing airline delays, slashing shipping fuel costs, or perfectly timing city traffic lights. This saves billions and reduces waste. Quantum simulations could model chemical reactions in batteries and climate systems, leading to cleaner energy, better materials, and a deeper understanding of climate change. However, there's a downside. Our digital world, including bank accounts and government secrets, relies on encryption. Classical encryption is based on math problems that take thousands of years to solve, but quantum computers could break them in hours or minutes. This is why governments and tech companies are racing to build quantum-safe encryption before quantum hackers emerge. Quantum computers could save lives or steal your passwords, depending on who uses them. So, where are these quantum computers? You can't buy one on Amazon yet. Today's quantum computers are in their infancy, like the room-sized computers of the 1950s. They are noisy, fragile, and require near absolute zero temperatures to function. Companies like Google, IBM, Rigetti, and IonQ are building machines with dozens to hundreds of qubits. But to truly outperform classical supercomputers, we'll need millions of flawlessly working qubits. This leads to quantum supremacy, when a quantum computer solves a problem no classical computer can. Google claimed this in 2019 for a narrow task, and while debated, progress is accelerating fast. You'll likely never own a quantum computer, just like you don't own a supercomputer today. Instead, you'll access quantum computing through the cloud, with services from Microsoft Azure, Amazon Web Services, and Google Cloud. One day, quantum computers might be working behind the scenes when you use an app to design materials, optimize business, or play games. You won't see them, but you'll feel their impact. This matters because quantum computers represent a whole new way of processing information, not just faster laptops. It's like the shift from horses to cars or candles to electricity. The world will never be the same. Challenges exist, and mainstream adoption might take decades, but their potential is too vast to ignore. Medicine, energy, security, finance, climate science, and AI could all be transformed in unimaginable ways. To recap, classical computers use bits, while quantum computers use qubits, leveraging superposition and entanglement to solve problems classical computers can't. They could revolutionize medicine, finance, logistics, and energy, but also pose risks like breaking encryption. We're in early stages, but progress is fast, and quantum computers could quietly reshape our world. So next time someone mentions quantum computers, smile and say, "Yeah, I know. And I'm ready for it." If you enjoyed this quantum journey, hit that like button. It helps the algorithm almost as much as entanglement helps qubits. Subscribe for more tech deep dives, and share this with a friend who thinks quantum is just a Marvel character. The future is weird, exciting, and coming faster than you think. Thanks for watching, and I'll see you in the next one.